Let x1, x2 on xn be a random sample from exponential distribution with parameter lambda, where lambda belongs to 1, 2. Now for testing h0 lambda is equals to 1 against h1 lambda is equals to 2, the most powerful test of size alpha will reject h0 if and only if. So we're asked to find the most powerful test for h0 lambda is equals to 1 versus h1 where lambda is equals to 2, and each sample from xi follows exponential with parameter lambda. So if we consider the joint density f lambda of x1, x2 and so on xn, so that is lambda to the power of n, exponent of minus lambda summation I is equals to 1 to n xi, and the likelihood ratio is nothing but f1 of x1, x2 and so on xn divided by f2 of x1, x2 and so on xn, which is 1 to the power of n e to the power of minus 1 into summation xi divided by 2 to the power of n e to the power of minus 2 into summation xi, which is 2 to the power of minus n into e to the power summation xi. So this MP test reject h0 for small values of, so since it is MP test we reject h0 for small values of this lambda of x, or equivalently large values, we can say the large values of summation xi, because we have this lambda following e to the power summation xi, and this decreases when summation xi decreases. So that means so basically this MP test, small values of summation xi. So since xi follows exponential with parameter 1, 2 times summation xi follows chi-square with 2n degrees of freedom, because n IID exponential 1 variables will add up to gamma n comma 1, and 2 times gamma n comma 1 follows chi-square with 2n degrees of freedom. So that means the summation xi is less than or equal to 1 by 2 chi-square 2n and alpha. So that means the summation I is equals to 1 to n xi is less than or equal to half times chi-square 2n comma 1 minus alpha. So that means option A is the correct answer.